But I'd just like to introduce Professor Chris Rapley as the director of the British Antarctic Survey, who will give our talk on polar regions. Just my own very anecdotal knowledge of Chris's accomplishments and activities. I know, for example, that he was the Secretary or Secretary General of the International Geosphere and Biosphere Program before he returned to the UK and did the world science community great service in that activity. So I'd just like to acknowledge that. And Chris, thank you very much.
Thanks, Steve. Well, good afternoon, ladies and gentlemen, everybody. Can I just check that you can hear me clearly at the back? A little wave. Good, thank you very much. Well, it's a real pleasure to be here to celebrate a great piece of British technology. There was a great debate a few years ago about whether science should be technology-led or science-pushed, or perhaps the other way around. In fact, the two things are completely intertwined, but every so often you get a piece of technology that opens up completely new windows and allows completely new science to be done. This is one of those. The UK took an inspirational lead on this. I guess the first thoughts were a long time ago, and so here we are now to celebrate what we've got, and you'll hear more about that this afternoon. Now, I've been asked to set the context, which is, as you see, why study the polar regions, something quite close to my heart. So I intend to give you a quick 20-minute gallop through the reasons why I believe the polar regions are particularly important pieces of planet Earth. And if we can get this thing to go forward, yes. We jump straight into a picture, Jim Hansen and co.'s image of the amount of warming that's taken part on the surface of the planet over the last 50 years. You can see there's been a general warming. We know it's about, 0.6 degrees Kelvin, something like that. But there are three areas where the warming has been much greater than elsewhere, about 5 times elsewhere. So that's Alaska, Siberia, and the Antarctic Peninsula, a few other little patches as well, won't go into those. And just in general, the physicists amongst you, and probably others as well, will have heard reference to and understood the ice albedo feedback, which is a positive feedback, which led people like Bodico 40 years ago to predict that the polar regions would amplify any anthropogenic gas-induced global warming, enhanced greenhouse effect. The idea being that if you've got a white surface of ice or snow, it reflects away sunlight, keeps the surface cool. If you blowtorch the snow and ice and expose a bit of ocean or land, it will absorb the heat, and you get a positive feedback. In fact, it's not quite as simple as that, because the polar regions are notoriously dark half the year, or thereabouts. And if you've got an exposed patch, it can lose heat quite effectively too. But by and large, the ice albedo effect works more or less the way it was predicted. And so at the root of these amplifications, that lies deep down as a physical process that can explain why this happens. Anyway, regardless of the mechanism, the fact is that the polar regions have warmed more strongly than pretty much anywhere else on the rest of the planet. And that has some consequences. The point being that regardless of the mechanism, if you have snow or ice somewhere near 0 degrees centigrade, a small incremental change in temperature will cause it to change phase. So you will go from a solid substance, which is sealing the surface either of the ocean or the land, to something entirely different, liquid that flows off and does something else. So if you look at the planet, and you're looking for places where something dramatic happens as a result of incremental changes in temperature, then it's the polar regions that you need to go to. And in that respect, they can be seen as the kind of miner's canary of change in the Earth system. So, amplification at the poles. Goodness, this is hard to work. Now, the animation is working, that's great. What consequences have there been of these temperature changes over the last 50 years? Well, what you're seeing there is a nice little animation which you can pull down off the web, which shows summer sea ice extent in the Arctic over this period, and the graph on the right just shows those data points as a function of time. And we know that from satellite remote sensing that there's been a 25% reduction in summer sea ice extent over that period of time, and there's even some evidence of a little bit of acceleration at the end. As I say, sea ice acts as a very effective lid on the ocean, very much reducing exchanges of moisture, heat, and momentum. And so if you reduce the amount of sea ice cover, you're going to have profound effects on the coupled ocean-atmosphere system in that region. So that's one major change that's taken place. Also in that picture,